Okay. Yeah. So as you all know, like this is a workshop based on mainly focused on the controller and the process, and we will see much more about the widely used entry level controllers such as Arduino, and we'll see more on how it works and how it constructed basically, like what are the aspects that you considered during the for a proper construction of a microcontroller and all. Okay, so this is the day one, day two schedules. So this is sorry, day one, day two agenda. And this one shows the brief about what all you people are learning in these 2 days. And as the host said, we'll be having a project demonstration uh, and a project challenge where you people will be doing constructing a circuit based on the problem statement that will be provided by the host at the end of this session. Okay, so coming into embedded systems. So as far I know, like you people are currently joining the second year, right? Hello.
Yes, sir.
So, okay, can anyone explain me what is an embedded system? Like, apart, what you like what you people know about embedded system? A basic. Yeah, anyone can answer. So there is no restriction on this. So you can just tell like what is an what you know about the embedded systems. Like this is just be more and more like a Q&A based session. So it will be easier if we have a better interaction between the host and the participants. So I am expecting answers in the coming slides as well. So if anyone knows, can explain me about like what is an actual embedded system means.
There are a few answers in the chat.
Oh, okay. So, a minute. Okay, for me the chat.
Shall I read them out?
No, it's okay. It's okay. I'm getting that. Okay, so yeah, one of the participants said like combination of both hardware and software. Yeah, actually you are right. If I'm not wrong, your name is Jnaneshwari, right? Jnaneshwari. Yeah. So yeah, as you said, like combination of both hardware and software defines an embedded system. Yeah. If you speak on the top level, like in a blank, like just a single line statement, this one suits good. Like yes, it is a combination of both the hardware and software, and it's designed for processing a function. Yes, that is also a proper word. But if you consider an embedded system, it's not only restricted with respect to a single function. Like for an example, if you take your any gadgets like a mobile phone or PS or your high-speed laptops. So these are all not defined to perform a single function. Like they are like it's designed to uh, designed to perform a variety of functions within which it is capable of. So that is the major one. So yeah, I think you people have some you people know something about embedded system. So I think I can. So here, we what the general definition of the embedded system is. An embedded system is a mix of hardware and software for a specific function or with a large system. So like an example, large system. If you consider a large system, so it might be a supercomputer, or it might be a R&D labs, or you can take for an example your server mines, like where people will be uh, do lot of calculations and all. Uh, is my screen is visible for you people? Just in case.
Yes.
Okay. I think I'll just flip it out. Wait a minute. Yeah. So okay. So about the embedded systems, so they are essentially miniature PCs, like a personal computer designed to control small features of a large component or without an OS operating system. So this statement signifies that most there is no necessity that each and every embedded system should have an OS. Okay, so OS is basically an like a managing what is it, a managing system which manage all the uh, micro instructions or micro process of an of a of a processor or a controller in a system. So if you are going with the OS base, then the application will be somewhat different. Or if you are not, or if you are going without an OS system, then the application may differ. So most of the embedded systems, like if you're seeing you can see in you can take example as a example, a oven, a microwave oven, or a fridge, or a washing machine. So these are type of embedded system controlled device which doesn't have OS. Like most of them doesn't come with OS. Like they will be pre-programmed, as mentioned here, pre-programmed, or they will be uh, user programmable sometimes. But it all again depends upon the end application, like in what way you're going to use the application. Okay, so yeah. So coming to the block diagram, like means a embedded system. Like if you are telling a embedded system, so many of you, someone of you replied like it's a combination of both hardware and software. So how, like in what way they are actually combined? So if you see in the block diagram, you will get to know, like there is one processing unit. In a rough way, we can say it as a CPU, like central processing unit, as you people may know. So there's a main controlling unit for which there are some inputs, there are some outputs. So in in computer, like in computer architecture, in a basic block diagram of a computer, if you're seeing the inputs may be like a keyboard, a mouse, or a scanner, and similarly output will be like your LCD screen and your printer. So that is what the input outputs are defined for PC. So likewise, in an embedded system, input output systems are classified as input systems. Inputs are classified as a sensor, and outputs are classified as an actuators or indicators or uh, transducers. Like, so there are so many input and output devices that can be used with this embedded system. Okay, so if you see in between these input and output communication, there is something called as the sensor conditioning and output interface. So these are pretty much essential blocks that plays major role in this embedded system. Like we know that okay, so if you consider keyboard as an input. Okay, so if you consider keyboard as an input, so for that your keyboard should have a proper interfacing option with your processor, so that your processor will identify like which keys you are pressing and what type of format that you are using. Like if you say there are different kind of keyboards that are available in today's market, like there are QWERTY format keyboards and WRTY format keyboards and split keyboards. So there are a lot of different type of keyboards are available. But for your CPU, like for your CPU, it doesn't matter like which type of keyboards it is using, but it should follow it should follow the standard format of representing, like representing the keys. So that's the major. So those things and all will be taken care by this sensor conditioning. Okay, so this is one of the example that I'm giving, like a keyboard. Okay, so instead of keyboard you can take the sensor as a camera, or an any sensors, like a gas sensor or a temperature sensor, anything like that. So this sensor conditioning will act as a what do you say, acts as a bridge between your uh, real time sensor unit with your main processor. Okay, so coming to the output interfaces. So output interfaces are like it's exactly opposite to the sensor conditioning. Okay, so if your sensors are like transferring a real-time sensor values into a appropriate signal that your processor can identify. The similar way, the output interfaces will convert your processor data into a particular data format that your actuators or indicators or your display systems will identify, understand. So this is a uh, this interfacing bridge will work on. Okay, so yeah, this is quite brief about this embedded system. So if you have people have any doubts on this. um, if anyone having any doubts, so they can drop it in group chat so that we can discuss on it, or otherwise yeah, we can continue. Okay, so okay, so as we are talking about the embedded system, so this is the first example, like the brief first like overview of how an embedded system is integrated uh, in our daily life scenarios. Okay, so this automatic coffee maker, I think okay, sorry guys, someone has asked like what are these peripherals. Okay, I'm coming up. Okay, so processors and peripherals. Okay, so peripherals is nothing but like your IO systems. Uh, Means if you consider a processor, okay, the processor will mainly have only a, a processing subsystems which helps, which only take care of processing the data. Like if you give two data, and and if you ask for an addition or subtraction, it will just do that and it will pop it out. But it won't have the ability to convert the data into some other form. Like an example, you are giving a input to the processor through a keyboard. Okay, but the processor won't having uh, any controlling system or any subsystem which helps the processor to identify which key is pressed and which what is the value of the particular key. So those things and all the processor won't be knowing. So there will be some subsystems called as peripheral systems which helps in bridging this communication between the processor and the IO devices. Similar way, the for output devices also the same peripherals will help in communicating. So this is what the peripherals means. Like I think in further slides, I think you people will have a better idea on what is exactly a peripheral and what is and why there is a two name called a processor and a peripheral. Okay, so yeah, coming back to our example. So if you see this coffee machine, I think most of you have, I think most of you people have seen already, like how a coffee machine works and what is the technology, like what and all technology it has. Like you can make your coffee through your smartphone, like just opening an app and providing the varieties and a flavor. Just in a single touch, it will make it out, make it for you. So how this system works? So that is the main thing that we want uh, to look into here. So if you consider a coffee machine, so these are the main entities like processor and subsystem, processor subsystems. So these processor subsystems is the like a heart of the heart of this embedded system where it which takes care of most of the most what do you say processing like for an example, you might have set set the device set the coffee maker to boil the what do you say boil the milk at particular degree Celsius and have a only one scoop of coffee or two scoop of coffee and these predefined what do you say these predefined inputs will be uh, taken care by these processing systems, which will store all your user data in the memory, so that in for the so that you are not you don't really need to uh, provide the inputs at every time when you are going to make a coffee. So once the data is feeded, it will take care. It will be storing in the memory, and it will take care whenever you are initiating any uh, initiating the coffee. Okay, so this is about the process system, and there's one thing or there's something called as IO subsystems. So in the previous one, there was something called as peripheral, right? So this is what this IO subsystems will take care of. So this IO subsystems is basically like taking the input from the user and providing it to the processor and fetching the output from the processor and retrieving it back to the user in a understandable way. For an example, like we users won't understand about binaries. Like if the data is shown in a binary, so it's very hard for us to identify what is what. In the similar way, a controller or a processor won't understand human language. Like if you just write a note like I need two scoop of coffee and one scoop of one scoop of sugar. So if we give the data like this, then even a processor won't be able to understand the human language. So these IO subsystems acts as a bridge in converting one form of data to another form, which helps the system to process the data and to provide the proper data. So this is the importance of the subsystem. Like if you can see here, there is some indication: this milk, water, beans, and salt. So these are like output. And if you're coming to bottom path, there is something called as communication subsystem. So this communication subsystem is the part which helps in communicating with the coffee maker. So if you see in earlier days, there were no wireless communication. Like wireless communications are rarely used in the fields in the daily fields. So at that time, it was completely wired, where a extension will be carried out from your device to some controlling unit, where you have some keypad and some controls, where you keep on pressing on it, and based on the suggestions given, it will take it up. So that is what uh, um, that is what happening when there was no proper there was no a wireless communication link. So but now in this fastly growing technological system, so here most of them now, like most of the devices are getting converted into a wireless system, where uh, it become a hassle free, like where you can just sit it and you can just be on one spot, and you can just what do you say you can just order whatever you want by sitting in a single place. So but the communication subsystems is taking care all this background works basically. So if you see this communication subsystem, it shouldn't it need not be only a wireless. So it can be wired, or it can be a wireless, or it can be something else like optical fiber based. It all it again depends upon the type of application that you are using, and type of and and it also depends upon where you are actually deploying the product. Like if you consider this coffee machine, you can say you are going to deploy in a public places. If this is not a coffee machine, if this is something like a scanner, a radar scanner, or a missile tracker like that, it's deployed in military field. So that is the final application where they actually differ. And yeah, so this is the brief about like how an embedded system is actually deployed in our daily life applications or daily life tools. So anyone have any question on this? Um, yeah. So yeah, coming to the next example. So the previous example, what we saw was like a what is it? Indoor, maybe an indoor instrument, indoor device or an indoor instrument like that. The next example, what you're seeing is like an outdoor. You can consider it as an outdoor. And yeah, so in this current world, I am sorry, excuse me. Okay, someone has asked what is bus. Okay. Um, Okay, so basically, what is a bus? Correct. So bus is basically a routing network. We can say, okay. So you people might know about the routers, right? Like network routers and Ethernet routers like that. So there, you may see like there is some RJ45 cable being connected from one router to another router. So say that like there will be five or six cables will be connected from one router to another router, and the communication link goes on continue till the end. So what is the need for that? So it's basically like communicating, like transferring a data from one point to another point in a form of an electrical way. So that that one we call it as a bus. Bus is nothing but a group of signal paths which carries the information from one point to another point. It's similar to your normal bus where people can transport from one destination, one part of the location to another part. So it's the similar way. In electrical term, like in electronics term, bus is referred to a bunch of electrical signal routes which travel from one part to another part. Okay. Yeah. Okay, so here I think I missed out this power supply part. Okay, so yeah, most of you people have know that if you are using a mobile device like a handy device, uh, you should have a proper backup power. Correct. Until and unless it's an wired device, so wireless devices should have a proper what is a proper power supply subsystems which helps them to extend their battery life, like instead of draining the battery for within an hour, it will extend the same battery life to like 1 day or 1.5 day, like that. So how this happens actually? So a power supply subsystems is basically a controller, what do you say? It's basically an embedded system. Like within it, there will be a small embedded subsystems will be placed, and they will take care of minimizing the power uh, by monitoring the each and every subsystem activities. Like for an example, if your coffee maker is not in on like not in any working, like user haven't given any data to start what do you say start making a coffee. So at that time, there is no use of switching on the heater or switching on the LEDs or some other systems like that. So at the time, you can switch off those systems in order to reduce the power consumption. Okay, so this is the way how the power supply subsystems will take care of the will look into the uh, power consumed by other subsystems, and also helps in extending your battery life. battery life and gives you more reliability. Whereas in wired subsystems, this power supply subsystems won't have that much effect, but this is like what you can say like in a CPU. In a CPU, if you observe, you will connect only one power cord from the CPU to the main supply. So rest all will be taken care internally. Like for your motherboard, there are different type of supplies that you needed, like 5 volt, 12 volt, 3.3 volt, and 1 volt, something like just several voltages required. So those things and all will be taken care by the power subsystems. Whereas in outer side, to the user, there will be only one power cord which will be connecting to the direct to the your AC mains. So that's what your power subsystems will do. Okay. So coming back to our okay. So yeah, what is a watchdog? Mm, okay, so watchdog. In the name itself, like you can guess, watchdog is nothing but uh, like a person or like an animal which is keep on watching the things. Similar way, watchdog is like an what is it? Watchdog will be like a event timer. I think you people might know what is a timer or what is a timer or what is an interrupt, correct? So basically, a watchdog is nothing but a small. It's basically a timer which keeps on monitoring all the subsystems, including the processor, whether operations are carried out in a normal manner, or is there a lag in the system, or is there some part of the subsystems is hang due to over processing, or due to some missing data, somewhat like this. So basically, Watchdog keeps all keeps on track of all these things, and it will intimate the user when there is abnormal activities. Like consider you're feeding multiple inputs to your coffee maker, which is not advised by the manufacturer or in the user manual. At that time, your processor won't have that capability of taking those many data. At that time, the processor may lag in process the information. So these things will be monitored by the watchdog, and it will what it will do, like it will intimate the user, and it will as well as it will intimate the processor that there's some malfunction is going on, so we need to reduce the load in order to balance the operation, like that. So basically, it's an interrupt. Interrupt means it will pop out from nowhere when there is some abnormal activities going on nearby. So that's basically what a watchdog timer does. Basically, the watchdog is most of the time it is called as a watchdog timer. If you check it out, if you just go and check it on Google, so you will get it as a watchdog timer or a watchdog interrupt, like that. Okay. So yeah, coming to our car. So I think you people might have known there are now there is a very good what is it? There is a very good technological advancement in the automobile field, where we can see EVs. Most of the cars are getting uh, redesigned in EV form, with the more what is it, more user friendly and more advanced. Uh, so how the electronics is really affecting in the EV, like in the automobile. So if you look into this picture, I think you will get to know like are what and all concepts are implemented. Like for an example, if you consider, there's something called as ADAS domain controller. So basically, ADAS is nothing but an advanced driver assistance system. Okay, so this ADAS is nothing but we can simply call it as a AI, or it's like you can just compare it with your Siri or Google or Alexa, like that. So which take care of almost all of your controls and monitors all of your device, all of your car status, and every each and every piece of information will be traced and will be monitored by this ADAS. So why this ADAS is required, really required? Because this ADAS will act as a main CPU for your car, where there are several sensors or IO devices will be equipped. For an example, this emergency brake system and adaptive cruise control. So this is like an output system where you people might know there is something called as ABS, like anti-brake, some full form is there. So ABS, it's a kind of technology where it uses a controller based system to in order to precisely uh, take care of the brakings in your cars and your in your bikes. Similar way, this emergency braking system and adaptive cruise control is also used for the similar concept. And cross traffic assistant. So this is nothing but an input. This is an input because this cross traffic assistance will be like a sensor modules where it will sense the nearby environment, and it will process the data, and it will fed to the your ADAS network. So whether the road is empty or whether the road is equipped completely tightly jammed, or whether there is any person or any object is in front of the car, like that. So in a such similar way, all the parts, like example charge port or interior camera, driving monitor, front view camera systems, cockpit domain controller. So these are like a bunch of embedded systems that are splitted in order to carry out a defined work. Okay, so these things are taken care or controlled by a main server. You can call it as a main server unit, or a master called as ADAS domain controller. Okay, so this is how the embedded systems are actually applied in electric vehicles or in automobile industries. Okay. Okay. So basically, ADAS is okay. ADAS is like I said, like ADAS is similar like a processing system. Okay, so basically like it will have the control over all your IO peripherals in the car, and it will automate, and it will take care of the, like it will take its own decision based on the data that is getting from the sensor. Whether for an example, um, if you're driving if you're driving in the car, and suddenly there is a hurricane or a thunderstorm is coming outside. So at the time, anyway, your AC will be, usually most of the cars now, will be having a AC, right? So at the time, what this ADAS controller will do is it will automatically switch on your AC, or it will automatically reduce the AC level, so that your interior presence won't affect based on your external presence. Okay, so this is how it will. This is how the ADAS controller or ADAS network will work. Okay, so it's not uh, a computer. It's a controlling a system. It is a controlling system. That's all. Okay. So yeah, moving out to the embedded system, like how they are divided, how they are classified. Okay, so based on the, actually embedded systems are classified into two categories. One is based on the performance and functional requirements, or based on the performance of the microcontroller. Okay, so if you come to the first point, like based on performance and functional requirements. Okay, so this is the part where all our electronic devices, smartphones, applications, everything will fall into this one. Okay, so where we'll highly check for performance, and we'll be highly focused on the functions. Like will be having some requirements. For that, we will be specified what type of system that we are going with. So that is what this category. So in this category, you can see it might be a real time. For an example, your cell phones or your smartwatch applications are standalone. standalone example, your microwave oven, or you can I can say uh, your fridge, etc. Network, yeah, your all your Ethernet routers or high scale networks, uh, or your what is it? Your server hubs like that, and mobile. Okay, so maybe the real time and mobile has some a small classification between them that we will see in the next slide. Okay, and about this, based on the performance of the microcontroller. So here, the most people, they will concentrate on the performance, irrespective of whatever, irrespective of their requirements. They will mainly focus on whether this particular processor or particular controller is capable of delivering delivering this performance. So that is one type of classification in embedded system. So basically, if you want to check okay, on a bit. If you want to see where this classification, like where they actually use this, uh, what do you say, this set of embedded systems, you can see it in manufacturing industries, or R&D centers, or some, what do you say, or somewhere, or in some labs where they are doing some groundbreaking observations or innovations like that. So that's why they are classified like a small scale, medium scale, and sophisticated. Okay, so going with the first part, like example of embedded system based on performance and functional requirements. So the real time, the real time is nothing but like where your data, like you need to process the data in a real time. You don't want any delay uh, between your input and output. So that is morely classified
ಕೂದ್ಲೆ
as,
ಹಿಂಗ್ ಹೋಗ್ತಿದೆ ಅದು ಹಾರಾಡ್ತಾ ಇದೆ ಬಾ
yeah.
ಗಾಳಿ.
Okay, so in real time, there's an example like a traffic control system, industrial automation system, and military subsystems. Okay, so these categories usually have real time processing, where they don't expect any delay in their process. So if there is a delay, then overall system will be collapsed completely. So that's why the real-time application is very much critical. Like real-time based processing systems are very much critical, and they're what do you say? They're highly powerful in some other reason. Okay, so yeah, standalone. Like standalone embedded systems are like where they don't require any other supporting device to operate. For an example, calculator. So you might have seen like in the calculator, you don't require any other some supporting devices, like your what do you say, your calculator screen is built in, and your keypads are built in, and your what do you say, your processings and your battery is also built in. So you don't want any external wirings or external connectors to connect your calculator with some other peripherals like that. One more example, like yeah, you can consider MP3 player also. Like if you are like if you go back for 5 to 6 years back, you might have seen like there are so many MP3 players, like handy MP3 players, where you just require a headphone to plug it and hear a song like that. Okay, so network is like home security systems. Like okay, so home security systems actually involves it's a big, what is it? It's a complicated systems where most of your IOs are interconnected very accurately, and what do you say? Mm, it's very you can what you can say, like it's the maintenance should be uh, taken care at the should be taken care more, because these kind of systems will have the failure rate. Like if these systems have failure rate, then your whole what do you say, whole security system or your communication system will get vanished off. So network based systems are what is it, it's very complicated, and the level of accuracy should be more. Okay, and in yeah, mobile means actually mobile is nothing but the one where mobile is like the device which you can take take out anywhere. Like it won't be means there is no limited restriction with respect to the area. Like for an example, if you consider a wired system, you can't take the device beyond the wire limit, because it is always connected with some external system. So you can't take it, you can't move it for a wider reason. Whereas your smartphones or digital cameras or your walkie-talkie or your iPod, so they're all they are like mobility devices where you can what do you say, you can take it out anywhere anytime, because you don't require any external subsystems to always get connected with them. So that's why they're called as mobile devices. Okay. So yeah, any doubts? Anyone? Hello. Okay. So so till now what you've gone through is like a bits and pieces, like just a part of what is an embedded system, how it works, and what are the process like that. Okay. So in this slide, you are seeing something called as Apollo guidance system. So this Apollo guiding system is considered as one of the best examples for your embedded system, like what is an embedded system and how it works like that. So I think most of us won't be knowing like when this happened, or what are the what are the technologies that they are used to perform these high level tasks like that. But this is how an embedded system is actually implemented in the real life. That's all. So this is one of the good, best example that we can have for an embedded system. Okay. So yeah, coming to sensors. Okay, so from the beginning, from the beginning of the what do you say? From the beginning of the slide itself, we are talking about sensors, I/O systems, sensors like that. So, why these sensors are taken that much of like taken or given that much of importance? Because the main reason is these sensors are the one which is capable of sensing the environment, like how the environment is and what are the changes the environment has, and it also helps in converting those information into a readable form or in a digital form where your embedded system can able to identify. So these are like basically a transducers. You people might have knowing, right? So transducers are the one which converts one form of signal into another form, like that. Okay. So if you see here, there are two type of okay, there are two images that are popped out. One is one of them is left side is having small sensors that you people are know, like these are like a like small scale, or what do you say, hobbyist sensors, uh, widely used for your what do you say, what do you use for your prototyping applications. Like these type of sensors will have, you don't have that much of accuracy, but these sensors will help you to, what do you say, help you to fix, help you to finalize your prototyping. Like these are a very low cost, and these type of sensors can be easily accessed and easily debugged when you're getting some issue with the sensor. Like, okay. Whereas when you consider the right side, so right side is where you're seeing like there's something transmission sensors, mirror sensors, wheel speed sensors. So these sensors are the type of sensors which are actually used in real life application, and these sensors are pretty much complicated, and the level of accuracy will be very high, because since these sensors are deployed directly in your real life application, so the level of precision should be high in order to avoid failures or any catastrophic damages like that. So I have taken what do you say, an EV car. So for this example, so if you consider a car, so these are the type of high-end sensors that usually your car will be equipped with. Okay, so if you see, there's a chassis level sensor, motor position sensors, differential non-contact angle sensors like that. So this is how the basically the sensors are classified, like a low level sensor and high level and high precision sensor. Okay, so yeah, so this is the one. This is like what are on which factor, like how you classify your sensor. So um, okay, so basically we'll classify the sensors uh, based on their nature, like what what type of application they are used widely used. Like for an example, if you take a temperature sensor, its main aim is to measure the temperature. That's all. It won't measure any other thing. It just sense the surrounding temperature. Whereas if you consider the altitude sensor, it will just measure the sea level altitude. It won't like there is no any other applications associated with it. So this is how the basically the sensors are classified. And if you coming to the if you go into the deeper side, so this is how what do you say, the whatever the listed in uh, this slide is how it's basically classified. Example, digital sensor or analog sensor. Okay, so basically the sensing, like whatever the nature is we all know that nature is completely analog. Like there is no digital form of representation of any sensing or any changes in the nature. So everything is a complete analog and completely undeterministic, where you can't determine the state of the what is it state of any object or anything in the surrounding. So based on this, the sensors also classified, like to sense the analog behavior of a device or of a nature. So the analog sensors are used. For an example, they can be sensing a temperature, or they can sense a pressure, sound, or altitude, or magnetic flux, etc. Okay, so like these are like sensing it in analog form. Okay, and there is one more classification, like the sensing will be either in analog or digital, but the communicating, like the sensor will transfer the signal, right? As we said, like it's basically a transducer which transfers the signal from one form to another form. So the another form, like whatever the sensor is sending to us, should be in a readable form, or it should be in some other form where we can easily access it. If it is not like if it is not in the form of which we can able to understand, then it's of no use. It's of no use. So if you consider like that, so they are basically like analog output and digital output. Okay, sorry. Yeah. So analog output type of sensors basically will have a output, like it will provide the data in the analog form, like where the data won't be a constant, like it will be keep on varying with respect to time, or it will keep on changing its amplitude with respect to time. Okay, so that's the basically how the analog sensor provides output. Whereas if you consider a digital sensor, so digital sensor, we know that in digital electronics there is only two acceptable states. That is, one is low level state considered as zero, and one is high level state considered as logic one, means in the logical interpretation. So these digital sensors uh, will provide the uh, will provide the output in the form of logic, like either zero or one. So there won't be any other intermediate state like that. So okay, so you can see the examples, like what are the sensors that actually comes in digital form, what are the sensors that comes in analog form. Like for example, PIR sensor, like it's a passive infrared sensor, which is basically uh, which is basically used to detect the motion of humans, or motion of any objects which poses IR radiation. Okay, and some other IR sensors, like IR sensors. You can also consider um, you can also consider what do you say, infrared, sorry, consider light sensors, where it will detect the presence of the presence of visible light. So those comes those things comes in digital form, like the output will be in the digital form, whereas for the analog form, the temperature sensor, pressure sensor, sound, there are much more. So these output won't be a won't be fixed to the logic levels, whereas it will have different values uh, according to the change in their behavior. Okay. Okay. So how will be the input? Okay. Okay. So if okay, we said like sensor. The main purpose of the sensor is to sense the surrounding. That's all. Nothing else. Like it will just uh, sense the nature, like how the behavior of the surrounding, and it will and also at the same time it will process the changes, and it will output in a readable form, like a digital form or analog form. Okay. So basically the input of the sensor is wide, like you can't guess which is the input. Like for an example, for a temperature sensor, the input is a heat waves. Okay. And for pressure sensor, uh, the input is an altitude, like how the altitude is varying. For a sound sensor, the input is a sound, like a distortion in the medium. So these are the inputs, like based on like there is no fixed state for the input, like this is the input, this should be the input, and this should be the output, like that. So the input of the sensors may it completely depends upon like what you're trying to uh, get from the environment. Okay. So that's how the inputs are classified. Okay. So coming to actuators. So if sensors are considered as an input, okay, so actuators are considered as an output. Like actuators, okay, so basically, and the actuator is nothing but a mechanical tool, or it can also be uh, taken as a mechanical device which converts your electrical form of information into a mechanical form, where there will be some uh, change in the angle of the angle or position of position of the sensor, sorry, position of the object, or it might be some momentary of the device, like that. So one of the best examples that you can think of for the actuators is the robotic arm. Okay. So where you are feeding the data, like you are feeding the information in terms of electrical forms, like your electrical forms, but the actually happening, like whatever the output displaying is the momentary. uh, I think you people might experience this two axis, three axis robotic arm controlled using a joystick, or controlling used okay. So no, actually, actuators is also a transducer. Basically, it's not opposite. Okay, so basically, the transducer is the one which converts one form of signal or one form of information to another form. That's all. Like it's just a bridge. Okay, so it won't classified into a sensor category or actuator category. Okay, so both sensor and actuator will come into a transducer category. Okay, so transducer is not like actuator is not opposite. Okay. Um, so okay, so this is one example is robotic arm. So if you want more example, like there is uh, the widely used piezoelectric buzzer. I think you people might have used in several projects, several small level projects. So these are buzzers, like if you provide some voltage across its terminal, it will start to produce a buzzing sound. So this is uh, what do you say, one of the simple example that you can give it for an actuator. Okay. So if you want to look into more on the operation, like how the piezoelectric works, then I think if you can check it, check it in Google, or like you will get a better explanation like how it produces a noise, like buzzing noise, by just by providing a voltage across its envelope. Okay. Okay. So this is the brief, what do you say, brief introduction or brief explanation about the embedded systems. So till now, any people have any doubts? We can discuss for some time. Anyone? Okay. So, okay, I think Meta understood. Understood. Okay, so coming to a microcontroller. So till now, what we learned is nothing but embedded systems. Okay, so embedded system is like if you consider embedded system as a, what is it, as a final product. Okay, this microcontroller is a part of it. Like it is the integral unit of it. Okay, so I since I don't think you people might have microcontrollers subject in your syllabus for now. I think so. Maybe in future, I think in your higher classes, maybe you might be coming through this microcontroller subjects, like what is a microcontroller, like that. Okay. So yeah, first question: what is a microcontroller? So a microcontroller is a compact integrated circuit designed to govern a specific operations in an embedded system. So before, like, wait, okay, here. So in this automatic coffee maker machines, like we have seen, there's something called as processor. Okay, correct, no? So this is called as processor. So what is the main purpose of this processor is to process all the information that is given by the user, and also process the information and communicate with the coffee making what do you say, coffee making circuitry or coffee making device to properly operate in accordance with the user's input. So those things are taken care by processor. Okay, whereas the processor was okay, so the processor was not only one complete block of this embedded system. There was input output subsystem, communication subsystem, and power subsystem. So processor was, what do you say, processor was combined with all these another subsystems in order to properly communicate and properly operate the entire device. So this is what the processor was doing. Okay, whereas if you consider this entire system, like including your processor subsystem, IO subsystem, power subsystem, and communication subsystem, so the entire piece is called as microcontroller. That's all. So that is a simplest way you can get the difference between a processor and a controller. Like a microcontroller is like a small part of, it is a small part of processing system which has uh, all the subsystems that is very necessary for one to handle the things. Okay, so if I come to, yeah, that's what here, that's what they are given here. A typical microcontroller includes a processor, sorry, a processor, a memory, and a IO system and peripherals on a single chip. So this is what the processor is. Okay, so sorry, this is what the what do you mean by control. Okay, so in the image you can see there are several type of microcontrollers that are listed out. I think few people might, or most of the people might know about Atmel, Atmel or Atmega, if I'm not wrong, since these are widely used microcontrollers in hobbyist projects. Okay, so there are some other microcontrollers called ARM-based controllers and PIC-based controllers. So these type of controllers are pretty much higher level, like complicated and higher end application controllers. Okay, so these things you will be studying in your what is it, in your higher semesters, but uh, but I think you can get to know what is the actual difference between these controllers. Okay, so I'm just deviating from the subject for now. Okay, so here I think you might be seeing there's a comparison given between an AVR and ARM. Okay, so this is what the comparison, like AVR microcontrollers means which are widely used in Arduino based development boards which equip this AVR based controller microcontrollers. Okay, it's basically from a RISC family. RISC family means again it's an reduced instruction set computing. So basically, if you study on the computer organization, like how the controllers or how the processors are developed, so there we can see a RISC and one more called a CISC, which is complex instruction set computing. So those two is the main family below which the all your microcontrollers and microprocessors will be classified. So similarly, ARM is also comes from the RISC family. Okay, but how they differ is here. It has a bus width of 8-bit or 32-bit. Means it can process, like the AVR is can able to process only 8-bit, from 8-bit to 32-bit of data at a time. Like it can't go more than that. Okay, whereas if you consider the ARM as a what is it, allocation for 32-bit and 64-bit as well. So this is why in most of your smartphones 64-bit operating system that comes from ARM. So this is one major advantage of it. Okay, uh, and it uses. Okay, so I think these things are pretty much new for you people, like the communication protocols and all. So for now, I don't I think you don't really need to worry on these, but you can just go through other differences, like it, its speed is 1 clock per instruction cycle. The same thing will follow here, but if you compare with AVR and ARM, most of the differences will be almost similar. But even though they are quite similar, but the overall operation speed or operation overall performance is completely different. Like your smartphones and your high-end uh, high-end laptop uses ARM-based microcontrollers and microprocessors. Once again. Yeah. Whereas your Arduino or your some other development boards which are very similar with Arduino uses AVR based. Okay. Yeah, that's how. And this is how, like this is the brief. Like this is just an raw image on how a microcontroller is developed. Like if you see in the first image, you can see like inside a microcontroller, there's a CPU, there's a ROM, there's a IO subsystems, there's a DAC, means digital to analog converter, and a RAM, and a clock, and ADC, basically analog to digital controller, sorry, converter. Whereas if you check for a microprocessor, then you only find CPU and clock and IO. Only these things will be there. Rest all things won't be there in the processor. So those things and all will be connected externally through the external network. Whereas in microcontroller, everything will be built in. So that's why the microcontroller is what do you say, is widely used in standalone devices where there is no much how do you say, there is no much processing power, where there is no much processing power is required. For an example, if you take your calculator, oh sorry, your calculator is a combination of both actually. So microcontroller, if you can take your smart LED, um, Philips or Cisco smart LEDs are there. No? So there you can control your LED your LED bulb using your Wi-Fi application. So that is the one that can be taken as the best example for your microcontroller. Okay. So the second image, whatever the shows, this is how the microcontroller is packed inside a chip. You might have seen in an electronics lab. You might be using some ICs to perform some logical operations like logical and or not like that. So if you open the IC, so this is how it will be. So the second image and third image is like pretty much like how they are constructed. So if you see it here, you will find all like ALU, register, plus decoders, controllers, everything. So this is just an overall an outlook of how a microcontroller will be. Okay. So coming to the next, yeah, this is this is a major like the difference between a microprocessor and a microcontroller. So if you see in the image, you might be seeing like for a microprocessor, only a CPU uh, will be inside a chip. Like if you take a microprocessor chip, only CPU will be there. Whereas your I/O serial interfaces, timers, RAMs, ROMs will be externally connected. So for an example, if you consider your laptop motherboards or PC motherboards, so you won't be having a CPU like Intel CPU or AMD CPU, like whereas the external systems like you will be adding extra RAM externally, and you will be adding ROM like SATA or SSD like that external. So basically, it's a microprocessing systems where you will connect all the other subsystems externally. Whereas if you come into a microcontroller aspect, everything will be built in. Like everything will be equipped in a single chip, where you can directly use the chip and uh, you can start developing your application, your end application like that. Okay. So yeah, this is some differences like what is the major pros and cons of both microprocessor and a microcontroller. Okay, so if you can see here, uh, the first three points, first 3 or 4 points is like whatever we seen already. The last point, like the major disadvantage of going with the controller and going with the processor. Okay, so microprocessor has a have advantage of versatility such that the designer can decide on the amount of RAM, ROM to fit the task at hand. Whereas microcontroller have the disadvantage of versatility because the user cannot add or remove the hardware inside microcontroller. Yeah, this is one of the major drawbacks that separates microprocessor and microcontroller apart. Like if you see in this image, in the microprocessor, the RAM and ROM are added externally, like where you will externally connect these RAM devices. Okay, so one advantage is like you can decide the depth of your RAM, like whether you need a 4 GB RAM or 16 GB or 32 GB, like that. It completely depends upon the user. So if you need more RAM, you can go on adding up. Whereas in microcontroller, since the RAM and ROMs are integrated internally, so there is no option like expanding. So whatever it comes, uh, it's fixed. Okay. So yeah, so someone asked like Raspberry Pi is a microprocessor as a microcontroller. Yeah, okay. So my Raspberry Pi is actually a microprocessor. Okay. So okay, so you guys keep these things in mind of whatever the differences that we are talking, like microprocessor and a microcontroller, like these are dated a decade old. Okay, like if you were in 2000 and to late 1990s, these differences were holding good for a microprocessor and a microcontroller. Okay, whereas if you check for this if you see in this 2020, like in the current technology, okay, a microprocessor can have a ability to work as a microcontroller, and a microcontroller can have a ability to work as a microprocessor. Like it's completely interconnected. Like processor, like processor will also come with all the IO devices ROMs internally, and also they will provide uh, access access to the user to add the like upgrade their systems externally, like which we are doing in microprocessor. So that is the current technology that is running on. Okay, so if you ask me whether a Raspberry Pi is a microprocessor or a microcontroller, so for I can tell like a 70% of a microprocessor, 70% of a Raspberry Pi is actually is actually a processor. Okay, so remaining 30% I can tell it as a microcontroller, because uh, if you look into the Raspberry Pi processor, okay, so you will see all these EEPROM, timers, RAM, ROM, IO devices, and serial interfaces. Everything will be already equipped inside a chip. So uh, these things are already inside, and they also provide external access to the user, where they can extend the what do you say extend the RAM or ROM or any other IO device if they need. So, so basically, like if you are, so that's Raspberry Pi. Yeah, for in a general term, you can consider it as a processor, because nowadays micro even a microcontroller is being called as a microprocessor, because even microcontroller nowadays coming or having a much processing speed equal to the microprocessor. So it's completely interchangeable now. Okay, so yeah, so coming to the Arduino. So I think most of you people are known about the Arduino. Like Arduino is widely used entry level what do you say entry level microcontrollers, which is very much which is very easy to learn and easy to deploy prototyping ideas. Okay, so yeah, what is Arduino? It's the basic question. Arduino is an open source electronic platform based on easy to use hardware and software. Um, a microcontroller board contains onboard power supply USB. Yeah, if you see in this image, okay, in this entire image, this is the Arduino chip. Okay, like is the AVR chip that we discussed earlier. No, so it's basically an Atmega 328P. It's the part number of the chip. Okay, and this is yeah, this is a port used for the programming, and this is a port used for supply power supply. Like it's a USB type A, where you plug into the system, it will start providing you supply and also communications. And these bricks uh, are used for IO communication, like where you can connect the sensors, and you can either connect the sensors, or you can either connect the actuators, depending upon the application. So yeah, it literally it consists all each everything that one required to start with deploying the project. Okay, it simply it simplifies the process of creating and controlling system by providing standard board that can be programmed and connected to the system without the need of any sophisticated PCB design and implementation. Yeah. So why this statement came here? Because I think you people might have heard about 8051, 8051, 8051 controller boards. Okay, so which is very older controllers that were used, which had a what is it, uh, which just had a controller, just controller. That's all. There were no programming ports available. There were no power supply ports were available. So everything was connected externally, or you should have used like you need to use some adapter boards in order to program it, or in order to communicate it communicate it with the device. Whereas in the Arduino, everything is built on a single platform. So that's one of the major advantage of going with Arduino. And one more thing is it is an open source hardware. So you might have seen nowadays open source platforms are gaining more gaining more appreciation in the current technology, because since each and every document or each and every files are open source, so anyone can access it and anyone can modify it. So there won't be any restriction with respect to the NDA agreements or proprietary or any such or any lawsuits kind of thing, where if you copy the schematics or copy the design of the Arduino and implementing it to in your own, like that. So it's basically open source because it started as a purpose of educating the engineering people with uh, with what is it with the industrial level uh, controllers and applications. So that is the main motto of the Arduino. Like when they were starting with when they started manufacturing Arduino boards. Okay. So in this image, I think you can see what are the different variants. Like what are the different variants of the Arduino board. So in this one, the Uno is much familiar and most popular among all, whereas Arduino Mega is higher end of the Arduino Uno, where it has more GPIOs more GPIOs for controlling, and it also has a higher it has more memory and processing capability when compared to Uno. Okay. Uh, okay. So form factor. Okay, actually, the form factor is an engineering term uh, which indirectly refers to a dimension. That's all. Like if you rewrite the statement, it will be like Arduino boards with different dimensions. That's all. Instead of dimensions, the engineering term is form factor. Form factor defines you the length, width, height, and the thickness, everything. So that's what the form factor means. Okay. So apart from Uno and Mega, Nano and Mini were the uh, latest Arduino release, which were very small, like whose form factor was very small, so that uh, uh, you can easily use it in in IoT devices or handheld devices or some other devices where the what is it where the size constraint was a major problem. So these two devices has equal capability of what Uno and Mega has, but they are very much restricted with respect to the with respect to uh, power and GPU capabilities, because since the board is very small, most of the things are cut down. Like most of the uh, controlling parts of controlling parts like external communication or what do you say mm, power power distributions, everything were chopped off, and they made it very small so that it will fit for a smaller application. Okay. So Arduino BT is like it's not originally from Arduino. Okay, so it's like a mixed. It has Arduino Uno in it, and it also has the Bluetooth functionality, where you can what is it? You can communicate to the Arduino using a Bluetooth communication. So these type of boards are used highly in IoT device, like that. Okay. And coming to the lily pad. Okay, so the lily pad again, it is also not from the Arduino family. It's some other, like there's one manufacturer. I'm not remembering the name, sorry. So they are designing this lily pad, which actually used in ornaments and in cloths, actually, because of its shape and because of the thickness or because of dimension. It's very easily fitted in most of the devices. And they also use this lily pad to make goggles, like rainbow goggles, where the lights, different light rainbow lights will be showed up like that. So okay, so why Arduino? I think we already seen much more detailed explanation here, so I don't think you might require this one. Oh, coming to Arduino. So this is what is that typical block diagram of an Arduino in proper form factor, like that. Okay, so if you see here, there's a reset button, there is a TXRX communication indicators, that's basically an output device, and on power relay indicator and ICSP. That's, these things and all we will discuss it. Okay, and at Mega 328, this is a microcontroller from AVR family, and a voltage regulator. I think you might have known what is meant by voltage regulator, and a crystal oscillator, which acts as a clock source for the for the controller, and a power button. Sorry, this is not a power button; it's a power input. Okay, so basically, if you see in this board, you have two power inputs. One is through USB, or one is through this barrel jack connector. So this connector is called as the barrel jack connector. Okay, so if if you are using your Arduino as a, what is it, as a prototyping, like you always need your laptop with this Arduino, and you all the time you keep on programming it, erasing it like that. So you can go with the USB based powering. Okay, when when you are when you are finalized with your prototyping and you started deploying your projects on site, like an example, like some other like some weather monitoring, or soil moisture detection, like that. At the time, you can go with barrel jack connectivity, like power input, where you can connect a battery into it. Then rest all things will take care of itself, like that. Okay, so these are two different inputs available. And yeah, coming to this ICSP. Okay, so the abbreviation of ICSP is nothing but in circuit serial programming. So okay, so basically why you need this pin? If you consider any microprocessor or microcontroller, uh, before user feeding the data, like user before you are programming it, or before you are actually planning of planning of deploying it anyway, there are some firmwares, like there are some basic bare metal codes, bare metal programs that's very essential for the microprocessor or microcontroller in order to operate, in order to function in its normal state. So those things you have to program it. But most of the controllers or most of the processors will come with pre-programmed. That is during the fabrication time itself, the manufacturer or a vendor will program it so that it will start accepting the user input. So otherwise, you can program it through some other pins, some other ways called. So that's why this ICSP pins are used. This ICSP is only limited with respect to AVR family. Okay, so if you are going with ARM based, that we saw earlier, the ARM based uses some other different uh, format, different form in order to program the ICs. Okay, so this ICSP is only limited with respect to AVR. Okay, so yeah, till now, any doubts or anyone? Okay, so yeah, next we'll go with the programming and Arduino. So till now, whatever we saw, it's completely hardware perspective, like how it will be, why it used, and what are its applications. So coming to next, we'll see how we'll program, like how the user is given the inputs to the microprocessor or microcontroller to perform a particular operation. Okay, so if you consider Arduino, basically Arduino programming language is a hybrid, like it's not completely a C, or it's not a completely C++. It's it's a combination of C, C++, and Java. Like it uses all this language as a base, and they developed a language which is easier for the user to what is it, there for them to adapt to it. Okay, so basically the Arduino programming syntax, basically the structure will have three main entities. One is hash include, one is void setup, and one is void loop. So these three are the basic entities. that will be that should be there in an Arduino programming. Okay, so as include is nothing but including any libraries or including any default libraries or user created libraries, like any special libraries like that. Otherwise, you can just knock it off. Like if you don't have any specific libraries to be included, you can just remove. Okay, whereas void setup is used to declare your variables, like an example, which pin of the microcontroller should be used as the input and which pin should be used as the output, and what are the variables used, or like what are the register names that you are providing. Those things and all those things will come in the void setup. And the void setup means the things that are put into void setup will only run only run only one time, like whether when you're powering on the board, or when your board is board is set to a reset. Okay, so this void setup is only a one time runnable code that you will provide. Okay, whereas void loop is something that keeps on running. Like there is no limit of there is no one to stop them. Like it will keep on running infinite times until till your board gets reset, or boards goes out of power. So basically your most of your functions, like most of your behaviors will be deployed in void loop. Okay, so this is the overall and how you need to program the Arduino. Okay, so coming to the next, yeah, this is what we're discussing, like void setup means what and void loop means what. Coming to the next. So if you see the pin mode, okay, so basically controller, like yeah, what do you say, Arduino controller, like the developers of Arduino, they are structured each and every functions, like each and every functions of the Arduino in a such a way that it is easier for the user to understand and easily to remember it. For an example, pin mode, so this is one of widely used keyword in the in Arduino software, which defines uh, what is the function of the pin, basically. Like we know that for a microcontroller there will be an IO subsystem, correct? So in order to work it as an input or an output, you have to define it in the code, basically. If you are defining it as an input, that particular pin will act as an input until and unless you are changing it to an output. So in order to have a proper what is it, proper communication, or proper uh, okay, proper communication establishment, you need to find set it whether the pin mode it should be a input or output in this particular keyword. Okay, so this keyword will have, like what all it will be included is the pin and the mode of the pin. The, so pin is the, like it's nothing but a which number, like which pin you're considering for this particular application or a particular function. Okay, so in this example you can see that pin mode 7 and taken as an input. So this is how it should be. And one thing is one downside of the Arduino is Arduino programming is it's a case sensitive. Okay, so if you are defining it in lower case, it will be in lower. You can't take it as an you can't consider it with uppercase. Okay, so whatever the keywords are there, it should be followed the same. Like the case alignment should be followed the same. Like in this example, if pin is in smaller case and M is in uppercase, you have to follow the same. Otherwise, your the Arduino compiler won't accept or won't recognize it as a valid keyword. Okay, yeah, I am coming to that one. So what is an input pull-up? Um, okay, so for this, in order to uh, understand what is a input pull-up, so basically, in every like in every microcontroller processing system, your input-output pins will be connected by a register divider network. Okay, I think you people know what is a register divider or a register divider network, where you will be connected a resistor across a across output of it, or for an example, input of a transistor or output of a transistor, in order to maintain a particular voltage level. So that is the basically that that can be that is the basic of pull up or pull down. Okay, so pull up, the name pull up is nothing but pulling the pin to logic 1. Okay, if the name is pull down, it's nothing but pulling the pin to the logic 0. So that's what the pull up means. Like the major, like why you need a pull up and pull down is because in some of the sensor application or actuator applications, the input, the default state of the pin should be assigned to either pull up or pull down in order to have a proper communication with the peripheral devices. So that's why this input pull ups or input pull downs are will come into the picture. Okay, so these things uh, will explain this in coming sessions. Okay, and the next more is the digital input. Digital input is like um, basically like is one of the keyword uh, where you try to take the digital data, means where you feeding the digital data to your controller. Okay, so that's what the digital input means. So if you read this, so to read digital input from a pin, that is whether it is a high state or low state, the function, the digital read is the keyword that is used to read a digital data to the pin. Okay, it takes the pin number as a parameter. For example, if a digital read of 7 means it will read the digital data which is present at the pin number 7. Okay, so if you change the pin number 7 to pin number 8 or pin number 9, and that particular pin will means that particular from the particular pin, it will, the controller will start to read digital data. So that's what the digital input means. Okay, so next, digital output. So on digital output, it's exactly opposite to the digital input, means where you are providing digital data at the pin. This one is very much the keyword is also very much similar. Instead of read, you have write, but here you have to specify whether the output is logic 1 or logic 0. Okay, so that will be your second parameter in this keyword. For example, here they are given the example, the digital write of 4 comma high means on the pin number 4, write a high bit or set the pin to high. That's what this digital write, like yeah, digital write keyword signifies. Okay, and coming to the next one is analog input. So this one is exactly opposite to your digital input. Means if in digital input means the controller or processor will start to read the data, like the data in the digital form at that particular pin, whereas analog input is like the processor or controller will start to read the data in analog form where you are specifying it. Like for example, if you are reading the analog, if you want to read the data at the pin number 7, you have to specify it as analog read of 7, so that it will start reading the analog data from that pin number 7. Okay, coming to analog output. Okay, so analog output is quite different compared to your analog digital output, because since uh, it's an analog, the level of the analog is not defined. It's not defined. Is not defined actually. So here There is something called as PWM. Okay, on it. Okay, that is pulse width modulation. I think these things are like this is a different concept which has specific application. That one we will discuss later. But generally, the analog outputs are defined in terms of uh, how much, like what is the level of the amplitude level at the pin, basically. So here we have taken the amplitude level in terms of speed. Okay, so you can just consider instead of speed, you can consider it as an amplitude level, or what do you say, or voltage level, anything you want. So the keyword is written in the way that analog write off the pin number, like which pin number you want to uh, provide the analog output and the output value. Okay, so basically, since you know that the processor or controller is a digital device, so in nature, it won't be having any analog, like analog output or analog input. So basically, there will be a conversion will be happening from analog to digital or digital to analog. That's why we are seeing in the earlier slide where we had a ADC and DACs inside a controller. So basically, this is used to uh, use it to convert your digital signal or analog signal from to the readable or writable signals for the processor or controller. Okay. So since you have a ADC and DACs, I think you people might have known about the resolutions and the steps that comes in ADCs and DACs. So those things will define your amplitude level in the analog rate. Uh, I think these things I will explain in detail when you are moving into hands-on, because if you just tell it in verbally, people won't get an idea like how it's exactly defined. Okay, so this is about the analog and digital inputs of microcontroller, basically an Arduino. So moving into interfacing with sensors. Okay, so now we learned about the basic of Arduino, and like how the pins are assigned as IOs, like pins are assigned as input or output. So now we will start looking into like how external sensors are, how an actuators are interfaced with Arduino. So that's what we are seeing here. Okay, so for one of the example, we are taking an Arduino and an unlock sensor. Like unlock sensor, let it be anything, like let it be a temperature sensor or pressure sensor or sound sensor or light sensor, anything. So this is a basic like construction, like how you connect the sensor with the Arduino. And in if you see in the pin sections, in section it is specified analog pins. Why? Because since the output behavior of the analog sensor is completely in analog, so you have to specify analog pin in order to capture the data coming from the sensor, analog sensor. So this is how the construction, and about the interfacing. I think once we get into hands-on, we can go into depth on like how we like what are the things that we will do, how we program the Arduino in order to accept the analog, and from the from the data that is getting from the analog sensor. So how to manipulate it and how to record it. Those things and all we'll discuss in hands-on. Okay. So and this is one more example on how you interface digital sensors. So if you see, there's no much difference. Instead of analog pins, you will be connecting to a digital pins. So apart from that, the remaining things will be same. And yeah, here also there will be a change in change in the uh, program, and there will be change in the process, like how you process it and how you record the data. So yeah, I think that's all. I think that's all for this today's session. So these are here I have we have listed few resources and few YouTube channels where you will get more details on this controllers or microcontrollers or microprocessors or some other uh, embedded some details. Okay, so these things I think these, you can check it out and you can what do you say, you can keep on learning. So yeah, that's all guys. That's all from my side. So if you people have any doubts, yeah, just put it on the chat. We can discuss for some time.
Okay, if there are no doubts, then we will be concluding the session. Thanks to the speaker and everybody else for staying throughout the session. Do attend tomorrow's session as well. Tomorrow we will start off with the project demo that explains how you have to actually use each component and how to write the code for each of them. And then we'll go on to look at other components and something more. As for the problem statement, it will be sent after tomorrow's workshop. And you guys will have one entire day to submit the solution for the problem statement. So thank you again. You guys can leave the meeting.